Welcome to Bike Guild, and today we're going to be talking about the concept of variables. So in a pattern-based learning approach, most people will show you what a variable is, and then they'll go through what a variable can do. Instead, we're going to talk at a conceptual level about what it means to be a variable. The definition of variable as a word outside of computing is not consistent or having a fixed pattern, liable to change, or able to be changed or adapted, okay, or an element, feature, or factor that is liable to vary or change. The important part here is change. It can mean something, and that something can be different from point A to point B. A variable in computing and in software development is generally going to be used as a name that refers to a thing. And I know in language arts class you were told never to use the word thing, but I'm specifically using the term thing here to mean an abstract, whatever that is. We're going to define what that can be, especially when we look at specific programming languages. But in general, a variable is a name, and that name refers. It refers to a thing. So what does it mean to be a thing? Well, the meaning of thing is going to somewhat vary based off of programming languages. In some languages, when I have a variable, it could refer to pretty much any thing, whether that thing is something that is principal to the language, like a numeric value, and something that is concretely understood, or something more amorphous like a dictionary, an object, something that has amorphous shape and we can change the meaning of on the fly. So this is an important distinction you have to immediately get into when talking about variables. In some programming languages, when we create a variable, we immediately define the contents of that variable, specifically what does it refer to and what can it refer to. We restrict what it can refer to. And what I mean by that is, in some programming languages, I can say, I have a thing in my hand. And that thing could be anything, meaning it could be a pen. It could be a marker. It could be a D20. It could be matches. It could be a cow. It could be a chicken. It could be a house. I could carry a house in my hand in some programming languages. It's totally viable and allowable. And then other programming languages, we're going to specifically narrow the definition of what can be held in my hand. And we're going to say my hand can hold a pen. And that could be this pen. It could be this pen. We might argue that this is a pen, this marker, but you can only be restricted to holding a pen. And this will be dependent on the programming language itself and the style the language was built to reflect. Some languages will be called strongly typed. And what that means is that we're going to provide this information as you write the code. So when you write your code, you're going to limit the definition to something specific. That way, we have confirmation of what is happening. Other languages may be called weak or loose. The definitions here in computer science are a bit subjective, but in these weaker languages, which I don't like the term, it's more that they're loose or dynamic. We are going to essentially not care about what is held in the hand from the perspective of restriction. And what that means is you could hold anything in that hand, even if it is, from the perspective of the application logic that you're building, impractical. For example, I could have a human that holds things in their right hand, and because there are no restrictions in that language, maybe I'm holding a cow or a house. These are where we can get some common pitfalls in bugs in some of these languages, but it also allows us relative flexibility and power because we don't have to supply these additional definitions. So bringing it back a little bit. Variables are one of the fundamental building blocks of application development. We're going to use variables to refer to everything that we are building. So if you need to define the age of a person in an application, you're going to use a variable to define that age. For example, here in JavaScript, we have an assignment and a definition and declaration. You're going to hear these terms. To declare is to create, right? When you make a declaration, you're making some type of statement of creation. To define is to provide a value to. So here we declare a variable named age. So we're going to refer to something as age. There's nothing magic to this name. We're just creating on the fly. And generally, when we're building names, we want them to be related to what is going to be stored or referred to by that variable. And there is a difference between the creation of a value versus a reference to something, but that is a more advanced topic that we'll touch on another time. For now, looking at this simple line of code, let age equal 37, what we're doing is we're creating a variable named age, and we can refer to it as age. And we are assigning on that right-hand side of the statement the value 37, the numeric value 37. Note, nowhere here do I say that this is a number. I just use a number. In JavaScript, which is dynamically typed, we are going to have the language infer the type for 37, for age, for what age refers to, automatically at runtime. And what that means is I essentially provide no type information here. Another thing to note is JavaScript is one of those languages that does not do any type of type enforcement. And what I mean by that is later on, if I wanted to say that the age is actually cow, I could do so. The string cow, the word cow. That's totally acceptable in the language. So I am never going to restrict in JavaScript what a variable can refer to. That name I'm using can refer to anything that is valid JavaScript. In a programming language like C++, however, I am going to very specifically be defining types at compile time. When I write my code, I must supply type information, or type information must be able to be inferred appropriately in the language. So here I'm creating a variable called age, just like we did. I'm declaring it age, and I'm defining it as an integer with value 37. Now I can go ahead then and say age is actually 99. That's totally valid and fine. What I can't do, because I defined it as an integer value, which is a counting number, a positive or negative counting number, I can't go and say it is something like the string Andrew. Now, I haven't installed any C++ extensions, but this code will not work when I go to compile my application. When I go and take my written code and it gets converted over into something that can be run, this will fail. And if we get more into C++, I'll explain why it fails and how it fails. But for now, what you need to know is that there are different classifications of language, and I know this makes it much harder. In general, on this channel, we're going to start off focusing on JavaScript. And the nice thing about JavaScript is it is simple. So in our simple definition, a variable is a name we give to refer to some value somewhere. Okay? Some values are very concrete and easy to understand. If we use the English word value, we can start saying, well, what are things that we refer to with the term value in English? And you might say, my bank account has a value of $3.75, right? And that's totally common, right? So gone, bank equals $3, and I forget what I said, 74 cents, whatever. $3.74. That's commonly understood. If you're talking about a bank value, we all know it's going to be a numeric, decimal delineated value, a decimal value. One of these floating numbers, which we'll talk about in another video. But essentially, we all understand intrinsically that a bank is going to be a numeric value. It is not going to be something like so. So if we say bank account value, $3.74, we know a bank account value is never going to be something like Bob, right? We just know that it's not. Now, that's not to say that you can't do this in the programming language, but generally a reader of this code is going to infer, if they see bank account value used, that a bank account value will have a numeric value that is a decimal, right? That's generally inferable just from common language, common use of language. We could also say color value. And when we're talking about color value, now we might not know, is an RGB? Is it going to be just a word that indicates the color? We do generally understand the concept of a color having value, right? The value of a color indicates what that color is. In the case of here, we might have color value name, and now we're very specific. The color value name, it's going to be blue, green, red, orange, what have you. So there are some things when I'm using the term value that you should be able to take from the world around you concretely and apply back. The challenge here is that when I say value, we actually can refer to elements that aren't found out in the wild of the world, things that are a little bit more abstract. So I can have a concept of let's say a lookup table. And this is an object here in JavaScript. And then I can start adding properties, key value pairs, where I have something like, some unique identifier over here, not even a part of language. And then that is going to provide me some information over here, which could be anything we want, right? And so when I'm building these constructs, they are not concretely grounded in a value that everybody understands outside of computing, outside of programming. They are not a value semantic type, some would say. Instead, when we look at them, they are more abstract in nature and more specific to the applications that we are building. And that is totally fine and okay. But it's important to understand that that's why I said a variable refers to a thing. It gives a name to a thing. Another important aspect that we need to consider is that a variable may refer to the same thing as another variable. So an example of this is, I call this my right hand. Somebody could call it my primary hand. Both of them refer to the same actual concrete hand, but they're two names that we've given for the same hand. The same thing can happen in coding. So here I have my lookup table that we've generated. Well, someone can decide that this is also referred to as a main table or some other name. And both of these names actually refer to this object that is right here. That is the concrete value that we're looking at, this object in memory. And two names now refer to it, and that's totally fine. And this is how applications start to get more complicated, right? We start looking at them and we see many names that refer to the same thing. And so it's important when we're building our applications to try and keep things as simple as possible and be considerate of naming. Naming is an extremely challenging aspect of software development. What do you name something? And later on, how do you make sure that that name is maintained clearly? I have a pen here, and we can refer to this as the pen, a black pen, an unused pen, because you can see maybe a little bit. It has a tip that has a piece of wax on it because I've never used it yet, right? And I also have a blue pen here, which can be referred to in any other way we want. Blue pen, new pen, other pen, second pen. So we have two pens here that are distinct from one another, right? They are discriminated against one another. They are discernible from one another. They have concrete values that are separate. But I can give them any name I want. And the same is true of a variable, right? I can use a variable to refer to this as the blue pen, and this is the black pen. I can refer to this as pen 1, this is pen 2, or this is pen 1, this is pen 2. I can refer to this is the pen, and later on change it to being this is the pen. And this is where all that complication happens. This is one of the things that's challenging for new engineers to grasp. The naming of variables, how variables are named, that variables may refer to other variable values. Okay, so as we're going and building applications, this is only going to get more complicated, but there are rules for how it works in every single language. And the trick is to learn those rules and internalize those rules. Some of the rules are ubiquitously applicable, meaning that they are fundamental to how programming languages are engineered and therefore apply to all programming languages, or the vast majority of programming languages. And we'll explore those in the future. So that's my kind of quick bit on what it means for something to be a variable. I'll dive into a greater depth about what variables are in JavaScript, how variables are used and referred to in JavaScript, and the different types of variables we have in JavaScript and how we can use them in separate videos. So if you liked this explanation, this analogous, is that a word? Explanation instead of a pattern explanation. Instead of looking concretely just at code, we talked about it conceptually and from a language perspective, then please write below and let me know that you want more things like this, more videos like this. To me, it's really important that we understand definitions and meanings, and that we can supply our own definitions and meanings to the common computational words we're going to use. So that's it for Byte Guild. Like and subscribe. Keep coding, and I'll come up with a really cool tagline sometime in the future. Thanks for watching.